Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be learning about two new definitions or two new small concepts relating to vector space only. The first one is the linear combination. You have obviously heard this term linear combination in my previous videos, but today we would be formally defining it. We would be understanding uske elements, actually वो क्या होता है, and then we would be using this particular concept of linear combination to understand what is linear span. Also, in today's video, we would be just learning about these two concepts, and in the next video, we would be using these two concepts to solve problems. So stay tuned. So here, if you see, the first definition that is there on the board is of the linear combination, which says that you take a vector space V over the field F. वो एक वेक्टर स्पेस है, and you have one more set S which consists of vectors alpha 1, alpha 2 and so on up till alpha n. Clearly this set is taken as a subset of this vector space. Mark my words, it's a subset and not a subspace. तो एक वेक्टर स्पेस है, हम उसका एक सबसेट लेते हैं, तो उसमें भी वेक्टर्स ही रहेंगे. We have taken a finite subset of the vector space. Then any vector alpha, this vector alpha belongs to your vector space V over the field F. तो कोई भी vector alpha, अगर we can express this vector in this particular form, wherein you are taken a1 alpha 1 plus a2 alpha 2 and so on up till an alpha n. It's not alpha 2, it's alpha n. Such that the scalars, or you would say the AIs, the a1, a2 and so on up till an belongs to the field F, and these alpha i's of course belong to the subset of V that we have taken. तो ये particular expression को we call it as the linear combination of alpha 1, alpha 2 and so on up till alpha n. Now why do we call it as a linear combination? First of all, हम ये जो सारे vectors है या फिर कुछ भी हो सकते हैं, like sum or all. So if you take them, or if you see this expression, it is in the form of a combination. They are combined together by addition operation as well as multiplication operation. जहाँ पे अगर आप देखो तो AIs are combined with alpha i's using the multiplication operation, and then that AI alpha I वाले term is combined with other AI alpha I वाले term using the addition operation. So the resultant that you get is a linear combination of the vectors alpha i's as well as the scalars that belong to the field F. और clearly यहाँ पे if you see there are no powers involved, AIs भी और alpha i's भी दोनों की भी powers one ही है. That is why we call it as a linear combination. तो अगर आपके पास कोई भी subset है किसी भी vector space का, और अगर आप वेक्टर स्पेस में से एक एलिमेंट को लेते हैं which in over here it's alpha, and if you are able to write that element in terms of the vectors of the subset that you have taken using the scalars belonging to the field, then the resultant that you get over here, it is alpha 1 plus a1 alpha 1 plus a2 alpha 2 and so on up till an alpha n. That particular resultant expression is called as the linear combination. So basically we are expressing any element of the vector space in terms of the linear combination of the elements of its subset. That is nothing but linear combination. यही concept use करके हम लोग अभी understand करेंगे what exactly do we mean by linear span, which is again an important concept which would be used in further solving problems. So यहाँ पे भी हम लोग एक vector space लेंगे V over the field F. You have a set S which consists of n vectors alpha 1 से लेकर alpha n तक, which is a subset of V. Always keep in mind कि ये जो subset हम लोग लेते हैं ये finite dimensional subset होता है, meaning the number of elements over here would be finite. Collection of all linear combinations. Again, why did I teach you the concept of linear combinations? क्योंकि यहाँ पे उन्होंने directly बोला है कि सारे linear combinations का collection, and we all know what do we mean by collection? एक set. तो ये एक set होगा जिसमें all possible linear combinations of finite number of elements of S is called as the linear span of S, and it is denoted by this particular set. Meaning जो भी सारे possible linear combinations है of S, अभी ये जो linear combinations है ये किसके रहेंगे? This would be of the vectors of the vector space. So जितने भी vector space के vectors हम लोग को इस linear span में represent करने को मिलते हैं, okay, we are going to take all those linear combinations and we are going to form a set. तो सारे, let's say कि if your vector space is having some 10 vectors and out of those if 3 vectors are being able to be written in the linear combination of a subset of that particular vector space, तो हम वो तीनों linear combinations एक set में लेंगे और जो भी resultant set मिलेगा of those 3 linear combinations is nothing but the set L of S, जिसको हम read करते हैं linear span of S. Understood? So this is linear span of the set S. So this is what the concept of linear span is known for, it is meant for. This particular concept is very useful because there are topics like dimensions and bases जिसके लिए हम लोग ये use करेंगे. So I hope you all have understood what has been taught. Yes, I would request you all to please check the previous videos also, because there are certain terms which I have used directly and you might have not understood it. That's because there are certain basic videos which have been taught prior to this video. So I would request you all to do check this playlist of linear algebra where I have started teaching vector spaces right from scratch. So I hope you all have understood. If you have any doubts, you can put them down in the comment section and reach out to me. Thank you so much and see you soon in the next video.